Good day. Welcome to our third lesson on graph interpretation with inequalities. In the first lesson, we discussed graph interpretation on a parabola and a straight line. Second one, we spoke about the hyperbola and a straight line. And in this third one, we're going to look at graph interpretation on exponential functions. So let's see what this question is about. The following sketch shows the graphs of fx equal to minus 2 to the x plus 4 and gx equal to 2 to the x plus 1 plus q with asymptotes pq and rs respectively. Now that is the asymptote of pq and this is the asymptote of rs. Take note that an exponential function only have one asymptote, where the hyperbola's got two asymptotes, a vertical and a horizontal. This one only horizontal. This is the asymptote of the f function, and this rs, the asymptote of the g function. In the first question, they ask us for the value of q. It is that q they are referring to. Now, the moment that I want to find an unknown within an equation, I always need to look for a point on this function. That is the gx function. Now, you can see it's labeled g. So on this function, you need to look for a point, and you will agree with me that's the point 0, 0. So that point is on the g function. So that means we're going to substitute 0, 0 into gx. So gx is 2 to the x plus 1 plus q. And we're now going to substitute the point 0, 0. So y will become 0, x will become 0, and then it's quite easy to solve for q. So we can now say q is equal to negative 2. Now that is all they ask us. I prefer always to finally write down the gx as well, because we're going to need it most probably later again, 2 to the x plus 1 minus 2. So that is now the equation of gx. And the question was to find q, and we calculated that q will be minus 2. In the second question, they ask us for the equation of pq. It is this asymptote pq. We want the equation, and that equation will be y equal to. So we just need to look at our equations given to us, and we need to determine what is that y value to be able to find the equation of pq. Now, this pq is the asymptote of function f. So if I look at f, you will notice there's a plus 4. So that means f moved 4 units up. And that means that that pq will be at 4. So we can write it down there so that we know that asymptote is at 4 because of the shift of the graph, 4 units up. So that means we can now say that the equation of pq is y equal to 4. This, you must write down the equation. You can't just say 4 only. You must say y equal to 4. We're going to follow the same principle to find the equation of rs. And this is rs here. So rs is the asymptote of function g. Now, you will just remember that we just calculated that shift, the q value of this particular function, which was minus 2. So it means that the g graph moved 2 units down. So that means that this asymptote will be at negative 2. So we can now say that the equation of rs will be y equal to negative 2. And those two equations represent the equations of the two asymptotes of the two graphs given to us. In the third one, they ask us to write down the range of f. So please remember not to take the correct one. It is the range of f that we are looking for. So we will say R for range of f. And of course, a range is always y. So if we look at this graph of f, you can see that this graph goes down to infinity and it goes up and it tends to that asymptote. So this graph will never cross that y equal to 4 line. So that means the range is less than 4 because we can't include the 4 because it's an asymptote. So it's all the y values less than 4. That is the range of f. So we can now say that y must be less than 4. So that is our range. If you prefer to write this range in interval notation, then you can say y is an element of negative infinity up to 4, and both of them will have an open bracket because 4 is not included because it's an asymptote, and negative infinity is always open. So let's move on to question number 4 on this example. Right, in this question, they ask us to determine the coordinates of A. First of all, go to your drawing and look for A, and you can see that is where A is. Now, similar to what we spoke about in the previous lesson, that is where the two graphs intersect. So that is a point of intersection. So that means we need to do simultaneous equations like we did in the previous lesson. So we need to take both equations of f and g, and we need to put them equal to one another. So let's do that. And that will help us to solve A. So we are going to write down the two equations and put them equal. So we say 2 to the x plus 1 minus 2 must be equal to negative 2 to the x plus 4. So we take the two equations and we put them equal. And now we're going to simplify this. We want all the variables on the left-hand side, all the constants on the right-hand side. So we're going to say that this is 2 to the x times by 2 to the 1, if I split this up. And then I'm going to say plus 2 to the x. It's this one that moved to the left, and that is equal to 4. And that negative 2, we're going to move it across, and that's going to be plus 2. Now, as you can see, on the left-hand side, we've got a common factor of 2 to the x, which we're going to take out. And we will be left with 2 plus 1, and that is equal to 6. So now we're going to divide both sides by 3. This 2 plus 1 is 3. We divide both sides by 3. And that will then give us 2 to the x is equal to 2. And this 2, the exponent is 1. So that means x is equal to 1. Because if the bases are the same, exponents will be the same. So that is the x value of that point of intersection, or the point A. So we still need to find the y value as well. And you can use any one of the two equations now to find the y value. So let's just use f. So I say I'm going to find the f of 1. So I'm going to substitute 1 into the function f. So which will be minus 2 to the 1 plus 4. And the answer will be 2. So that means now that the coordinates of A will be x equal to 1 and y equal to 2. So that is the point 1, 2. So we can put this on our drawing. Point 1, 2 is that point A that we have. In the next one, they ask us to find the coordinates of B. If you look at the drawing, you will see that is B, and that is the x-intercept of function f. So we're going to take the f function and we're going to find the x-intercept of f. So I'm just going to say x-intercept of function f. So that means we're going to substitute y with 0. So we're going to get minus 2 to the x plus 4 is equal to 0. So that means that 2 to the x is equal to 2 squared, because 4 we can write as 2 squared. And that means that x is equal to 2. So the coordinates of B will be x is 2 and y is 0. So that point on the graph will be at 2. So with that, we calculated the coordinates of B. Now, they also ask us for the coordinates of C. And C is the y-intercept of function f. So we took function f, we worked out the x-intercept. Now they ask us for the y-intercept of f. So let's do that. So I'm going to say the y-intercept of f. That is where we substitute x with 0. And we will then get y equal to minus 2 to the 0 plus 4. And now you must be very careful here, because 2 to the 0 is 1, but there's a negative outside, so it's minus 1 plus 4. So that means y will be equal to 3. So the coordinates of C will be x is 0 and y is 3. So I'm just going to put that 3 on our drawing as well, is that y-intercept. You will remember that that asymptote was at 4 and this asymptote was at minus 2, if we put that on the drawing. So with this, we calculated these 3 coordinates. So let's look at the following question. In question 5, they told us that OD is equal to 1 unit. Determine the length of EF. So let's just look at the drawing. They told us that OD is 1 unit. But you can see D is on the negative side. So that means that X value there at D will be at minus 1. So the first thing we can write down is to write down the coordinates of D. So D will be minus 1 and 0. So that is what was given to us. Remember, a length is always given as a positive value, like they told us there, it's 1. But when you go to the drawing, you will see in the position is at minus 1. So this X value is minus 1, and they ask us to find the length of EF. Now, to find this length of EF, we need to find that Y value, and we need to find that Y value. So we're going to take this X equal to minus 1, substitute it into F, get the Y value, substitute minus 1 into G, and that will give us that Y value. And those two Y values, the positive values, we will add to find the length of EF. So let's just do that substitution. So first of all, we're going to find the F of minus 1. So within the F function, I'm going to substitute minus 1 into X. So we will get minus 2, and the exponent was X, which is now minus 1, plus the 4. And now we must simplify this, and you must be careful when you simplify this. That negative is outside. 2 to the minus 1 is the same as a half plus 4. So that means our answer will be 3.5, or we can write it as 7/2. So that is then the y value if x is -1. So we basically calculated now the coordinates of E. So that coordinates of E, we can say here, will be the x is -1 and the y will be 7/2. Now we're going to do the same thing, but this time we are going to use the g function, this g1. And we're going to substitute the x value of -1 into g. So we find the g of -1. And you remember that equation was 2 to the x plus 1. So we now get 2 to the -1 plus 1 minus 2. And if we simplify this, -1 plus 1 is 0. So that will give me 2 to the 0 minus 2. And that will leave you with 1 minus 2. And that is -1. So we can say now that the coordinates of f, the x will be -1 and the y is -1 as well. So what we calculated now was that y value and this y value. So this one is at -1 and that one is at 7/2. Now again, we want a length. We want the length of EF. Now to get the length of EF, we need to take this distance plus that one. This one is 7/2 or 3.5. And this one, the length, the position is -1, but the length is 1. So we're going to add those two. So we're going to say that it is 7/2 plus 1, and 1 is the same as 2/2. In question number 6, they ask us to explain how the graph of G can be transformed to produce the graph of F. There's also a hint given to you that this transformation consists of 3 steps. So they want us to start with G, apply 3 transformations on it, and that will give us F. And we need to say what these transformations are. So first of all, we're just going to write down the 2 equations. So Gx is 2 to the x plus 1 minus 2. And fx is minus 2 to the x plus 4. Now we're going to start with Gx, and we're going to apply the transformations now. So let's see what we need to do. If you look at G, you will notice in the equation as well that this graph of G moved 1 unit to the left. Please take note that +1 means horizontal shift is opposite sign. So you put x plus 1 equal to 0, so x equal to -1. So this graph moved 1 unit to the left. As you can see, F didn't move at all. So that means to change this one to look like that, we need to shift this graph 1 unit to the right. So that is the first thing we're going to do. We're going to say 2 to the x plus 1, and then we say -1 for the shift to the right, and that -2 that is still part of this equation. So that is only to do that horizontal shift. It's 1 unit to the right. The second thing that we need to do is this G, as you can see, is an increasing function and F is decreasing. So that means we need to reflect G in the x-axis to try to get to F. So we're going to do an x-axis reflection in the x-axis. So that means y becomes negative. Now, for us to make y negative, we're going to put this whole thing in a bracket, and we're going to put a negative outside. So we're going to take this function, first of all, this gx function, shift it 1 unit to the right, and then reflect it in the x-axis. But there's still a last one. Now, as you can see, that this graph, once we reflect it, with that negative, we'll change this 2 to a positive 2, but there's a fall. So that means we must still move it 2 units up. So we're going to say plus 2 outside. So the order is here quite important. So now, if we simplify this a little bit, we will get minus 2 to the x plus 2 plus 2. So that negative times this negative plus that 2, and that will give us minus 2 to the x plus 4. And as you can see, this is fx. So there we did the transformation. So what did we do? We shift 1 unit to the right. So if we want to just to summarize this, we shift it 1 unit to the right. Then we reflect in x-axis, and then we move 2 units up. So that is basically the 3 transformations. A shift 1 unit to the right, a reflection in the x-axis, and then we move it 2 units up. That is what we need to do with G to give us F. So now for our last question on this lesson, and that is the inequality one. So you can see they again ask us for a product to be negative. Now, like we said in the previous lesson, for a product to be negative means they must have opposite signs. So this one is positive and that one negative, or this one can be negative and that one must be positive, and that will give us also a negative. So different signs. And you will remember, when we want the product to be positive or negative, the signs of these functions change at the point of, not the point of intersection, but at the x-intercepts rather. So we're going to go to this drawing, and we're going to look at the x-intercept, which is at 0. There's an x-intercept. And at 2, there's also an x-intercept. Now I'm going to draw 2 vertical lines, one at 0, one at 2, and then we're going to look at the 3 intervals to see which interval will give us the answer. So as you can see, there are my 2 vertical lines. And I say again, I draw these vertical lines at the x-intercepts of these 2 functions. So we've got 3 intervals to look at. There are no vertical asymptotes now, like in the previous lesson. So we're going to look at this interval from 0 to negative infinity. Then we're going to look at the interval 0 to up from 0 to 2, and then from 2 to positive infinity. So let's see what happens in this interval, less than 0. So you will notice that the graph of f is positive and the graph of g is negative because it's below the x-axis. So that means the product is negative. And you will agree that is what we are looking for. So let's write down the solution. X will be less than 0. We're not going to include the equal because, as you can see in the question, there was not an equal given to us there. So therefore, no equal here also. So that is one solution. Now we look at 0 up to 2, that interval. And as you can see, pretty clear that both functions are positive. So that means the product is positive, and we don't want a positive product, we want a negative one. So let's look at 2 to infinity. And as you can see, that G is positive and F is negative. So therefore, the product is negative. So that is another solution. So we can say X is less than 0 or X is greater than 2. Not equal, because no equal in the question given. So the answer is only X is less than 0 or X is greater than 2. Thank you.